The People's Liberation Army Navy plan of China is planning to acquire a class of third-generation nuclear-powered assault submarines called Type 095. The Type 095 submarine is expected to have an upgraded hull type and a significantly lower acoustic signature. The People's Liberation Army Navy submarine force in China is expected to acquire the Type 096 class of ballistic missile submarines, SSBN. The JL-3 SLBM will be installed on the submarine, which is anticipated to start construction in the early 2020s. The Type 095 will include a more sophisticated nuclear reactor, VLS tubes, and more sophisticated sensors, including a new active, passive flank array sonar and a low and high-frequency towed sonar array, than the Type 093. Furthermore, it is hypothesized that Type 095 submarines could serve as an underwater escort for any upcoming planned aircraft carrier task forces. According to reports, the submarines would be constructed at a new facility owned by Bohai Shipbuilding Heavy Industrial Corporation in the Liaoning province of China's Huludao Prefecture. Planned nuclear submarines of the third generation may be equipped with hybrid propulsion, turboelectric drive for silent, slow-speed propulsion with a maximum speed of 8 to 10 knots, depending on the submarine design, SSGN versus SSBN, and turbo reduction for high-speed operations. The Russians are said to have implemented the identical propulsion plant configuration in the Project 955 and 955A Boret class SSBNs. The plan's third-generation submarines will undoubtedly have a sizable horizontal raft that can float freely. Large rafts with very low-frequency airbag isolation devices are, in fact, described in a number of patent applications. Particularly, one application offers an isolation idea that is strikingly comparable to that found on the Project 949A Oscar II and Project 971 Aquila 1 submarines. In order to separate the raft platform from the submarine pressure hull, the isolation system design in this application incorporates both vertical and lateral big pneumatic mounts. A significantly bigger pressure hull diameter than the 9 meters of the first two generations of nuclear submarines will be required for the employment of a large horizontal raft with 2 levels of the JYQN series of pneumatic isolation mounts. One of the plan's top priorities is probably being able to secretly fire land attack cruise missiles, like as the 1,500 km range CJ-10. A transport launch canister, TLC, up to 9 meters long and 0.85 meters in diameter can be used with the plan's Universal Vertical Launch System, VLS. This TLC is much larger than the U.S. Tomahawk capsules associated with the Mk-45 Mod 1 SSN VLS and would be needed for the CJ-10. Additional weapon choices include the YJ-18A ASCM and the Anti-Ship Ballistic Missile, ASBM, which was tested from a Type 055 destroyer in April 2022. According to the Universal VLS, the ASBM would need the biggest TLC possible, and the YJ-18A would also, depending on how the exhaust vent channels require a large canister length. Therefore, compared to a US SSN, the launch system and hatches of a comparable Chinese submarine system should be notably larger. Although it is essential for surface ships, submarines do not necessarily need to be able to launch the YJ-18A SCM from a VLS because Type 039A, B, C, and 093 submarines can launch this ASCM from their torpedo tubes. However, a submarine can greatly increase the size of its salvos using a VLS system. Numerous sketches and a possible model displaying distinct VLS tubes are included in online estimates of the Type 095 SSGN design. A Virginia payload tube-like launcher with 3 cells per tube has been described. However, it appears to be more of a conceptual design. It would appear plausible that the Type 095 SSGN will also contain individual VLS tubes for testing, like the Type 032 does. Although the exact number of VLS tubes is up for question, fan art depictions and concepts suggest that there are typically between 12 and 18. However, PRC experts showed a single row of submarine launch tubes 3 across in a 2016 article that was published in Ship Science and Technology. As in the Type 032, the missile tubes are evidently able to pass through the pressure hull, and the author's analysis appears to assume that the number of tubes in a row is a given. The Type 032 has a maximum beam of 10 meters, meaning the pressure hull is between 8 and 9 meters in diameter. Therefore, if the plan intends to place 3 tube rows in the Type 095, a pressure hull diameter more than 9 meters will be required. The Type 095-096 submarines will obviously need to be significantly larger than the second generation when all of these criteria are taken into account. An increase in the diameter of the pressure hull is required by the reactor, the big floating raft, and, to a lesser extent, the VLS. It makes sense that the new designs must have a hull size comparable to a Russian submarine with comparable qualities, notably the Project 971 Aquila, which has a pressure hull diameter of 10.9 meters, assuming Chinese designers are utilizing a reactor and sound isolation system of Russian provenance. This argument is supported by evidence, although it is difficult to condense all of these into a very crude design. The Type 095 SSGN and Type 096 SSBN projected designs. The Type 096's missile chamber is expected to have a diameter of 12 meters in both scenarios. If the propulsion plant solely employs a turbo reduction technique, both submarine classes should be extremely quiet, on par with the Project 971 Aquila 1. The acoustic noise levels may be comparable to a Project 971 new improved Aquila 1 SSN at tactical speeds if the above-mentioned hybrid turbo reduction/turboelectric technique is used. The hulls of the Type 093 and 094 submarines were simply too tiny to fully utilize the established technology. China is now almost ready to produce top-tier nuclear-powered submarines, over 50 years after the first Type 091 SSN was put into service.